Welcome to Earth Science with Mrs. Miller at Buena Vista ISD. Today we're working on Unit 8, the atmosphere, and we're focusing on Chapter 15 loosely. So we want to be looking at some certain vocabulary. We want to be looking out for the word atmosphere, troposphere, ionosphere, ozone layer, ultraviolet radiation, and chlorofluorocarbons. So, we also want to be able to identify the gases within the Earth's atmosphere and describe the structure of Earth's atmosphere and explain what might cause atmospheric pressure. Now, let's take a look at this crater. And you might assume that it's on the moon, but it's really not. It's taken in Africa, Australia, this picture is. Now, an impact like this is pretty unusual on Earth. So, why is the moon most likely to encounter impacts of craters than the Earth? That answer needs to be put in your listening check journal. Okay, so let's go on about the importance of Earth and its atmosphere. So basically, atmosphere is a thin layer of air that's like a protective coating, almost like skin or the cuticle on a plant. Now, extreme temperatures and radiation is stopped via this atmosphere. Now, life as we know it wouldn't be possible without this atmosphere. So, what makes up our atmosphere? Well, essentially it's a mixture of gases, solids, and liquids. It extends from the Earth's surface into outer space. About 78% of it is nitrogen, and about 21% is oxygen. And then we have some argon, carbon dioxide, and some trace other elements. Now, we also said there were solids in there, and that includes dust, pollen, and salt. And the liquid is obviously water. And then we have some extra interferes that we as humans put into the atmosphere, and that includes pollution, smog, exhaust emissions from our cars, and something called CFCs, chlorofluorocarbons. Now, we said that the atmosphere went from the Earth's surface into outer space, but we need to be able to break those down into layers, and those layers are split up actually into two zones, the upper zone and the lower zone. Now, the lower zone contains the troposphere and the stratosphere, and the troposphere has about 99% of the water vapor and 75% of all the atmospheric gases. And it only goes about 10 kilometers high. That is followed by the stratosphere, going from about that 10 kilometer mark to the 50 kilometer mark. And in here lays the ozone. And I'm sure you've heard a little bit about that, but we're going to delve into that a little bit more here in a couple slides. Now we have the upper zone, which is the mesosphere and the thermosphere. And in that mark, at that 85 kilometer mark, is that ionosphere. And that ionosphere is a layer of highly charged particles that during the day absorb AM radio transmissions and some other wavelengths. But at night, they don't absorb it. So we're able to hear long distance radios. That's what AM radio is, long distance radio waves. So we can hear radio from, say, Canada or Mexico. Something called like coast to coast AM radio. Now, the thermosphere has very high temperatures, even though it is the thickest layer, running from about that 85 kilometer mark to the 500 kilometer mark. And the mesosphere running from that 50 kilometer mark to the 85 kilometer mark. And that's most notably known for its meteor showers. And then above that thermosphere is the exosphere. And this is basically where the space shuttle orbits. Now, we've heard some words about atmospheric pressure and stuff like that. So let's just take a pause and think about that. The further up a mountain you go, the less pressure there is on you. And it's a twofold reason. One, there's just less things on top of you. And two, because there's less things, there's not as much pushing. And that allows the particles to move away from each other. When they move away from each other, they're not pressing down in one particular place. So that's why if you run at the top of a mountain, you're going to get out of the breath faster because there aren't as many air particles close together for you to breathe. So I need you to pause, take a second. You need to be doing your problem-solving activity on page 436 in your listening check journal. Okay, let's move on to what's going on in the temperatures as far as atmospheric layers go. Now, these layers are sort of similar to the layers of clothes we put on. An outer layer almost being that protective layer, keeping not just the cold out, but keeping rain out. And it's sort of almost a repellent. The atmospheric layers sort of work that way, but instead of keeping it out, they actually absorb it. They absorb it so that it won't go into the lower layers. Now, the atmospheric layer is meant to absorb that sun's radiation and heat, so this causes the different layers to have some different temperatures. Now, we know the thermosphere, which is closest to the sun, has that highest temperature. But let's take a little bit of a different picture. Because in the troposphere, for every kilometer away from the Earth's surface, the air temperature decreases by 6.5 degrees Celsius. So let's take a look at this picture. Let's make it a little bit bigger here. Okay, so the troposphere, that's this bottom layer right down in here. Right in here, this 10-kilometer mark, being really at the peak of Mount Everest. In that troposphere, for every kilometer we go up, it goes down 6.5 degrees Celsius. Now, if you notice that once we hit that ozone layer, that maximum ozone layer hitting at that 25-kilometer mark, it actually begins to go up again. And then it sort of zigzags back and forth. But what we're concerned is about us. So in that troposphere, we know for every kilometer up, 6.5 degrees Celsius over. Okay, we'll put that picture back into place. Okay, so that ozone layer, we saw that 25 kilometer mark. We know it's in the stratosphere, and it does extend out from that 19 to 48, but it's most concentrated at that 25. Now, ultraviolet radiation is one of the many types of energy that the sun is able to send out. Now, the ozone itself, the whole purpose of it is to absorb most of the ultraviolet radiation from the sun. Well, ozone's O3. How did it get there? Well, early Earth didn't have much oxygen floating around. It was almost uninhabitable because of the non-existence of oxygen. However, as plants began to develop and became photosynthesizers, one of the byproducts of photosynthesis is oxygen. So they were able to take the carbon dioxide and release the oxygen into the air, and it actually sort of built up within that troposphere and sort of pushed up, creating the ozone, which trapped even more of the oxygen, which allowed life to exist. Now, since we're on that ozone layer, we have to talk about CFCs in the ozone hole. Now, the ozone hole is a seasonal thing. It does happen, and it's a hole that creates in the ozone, basically over Antarctica. Now, each year in late August, early September, that hole begins to decrease over Antarctica. But by October, it's at its lowest point, and then December, its hole almost completely disappears. But we can influence that hole simply by emitting chlorofluorocarbons, those CFCs. Now, we don't want that hole to be large, because if that hole is too large, we're going to get some polar ice cap melting. We're going to have overexposure to ultraviolet radiation, all kinds of stuff. But what are CFCs? Well, basically, they're chemicals in refrigerants. Air conditioning units, your car AC, aerosols, and foams also. Now, these completely break down the ozone, which is that O3, and separates it up into two parts. One being the ClO, which is chlorine and oxygen, and O2. And neither of these can absorb that UV radiation, so it allows it to hit Earth and allows certain areas of the Earth to increase in heat. If you notice, this is a thermal image from 2006 in September, and we're noticing this very large hole almost covering the entire section of Antarctica. But again, in December, I understand this is 2009, that hole is almost gone, or is actually completely gone. All right, so it's time for a listening check. Be sure to record your answers in your journal. And so just make sure you were listening and not just watching the video. Early Earth had very little oxygen. How did oxygen come to make up 20% of the atmosphere? I also want you to list in order the parts of Earth's atmosphere. Tell me, why is it harder to breathe at the top of a mountain than at the bottom? Give me an effect of the thinning ozone. And tell me why we can only listen to that Mexican radio station late at night rather than during the day. Thanks and have a great day.